Assalamualaikum and good day everyone. So today we go to chapter 8.4, interference of the reflected light in a thin film. For learning outcome 8.4a, you have to identify the occurrence of the phase change upon reflection. Okay, so here a light wave travelling in a medium of lower reflective index N1 when reflected from the medium surface of higher refractive index N2 undergoes pi radian phase change. Alright, so kita tengok kat sini. N1 is less than N2. So the light wave is travel from less dense medium to denser medium. Okay, to denser medium. So kita tengok kat sini. From less dense to denser medium, so there will be phase change. Okay, there will be phase change sebanyak pi radian. Cakap apa? The light wave travelling in a medium of lower refractive index, okay, when reflected from medium surface of higher refractive index undergoes pi radian phase change. Okay, so ingat, when the light travel from the less dense medium to denser medium, dia akan undergoes phase change sebanyak berapa? Sebanyak pi radian. Okey, kita tengok yang kedua. Dia cakap apa? A light wave travelling in a medium of higher refractive index, okay, when reflected from the medium surface of lower refractive index undergoes no phase change. Okay, so contoh kat sini, N2 less than N1. Contoh kita ada N1 is 1.52, N2 is 1.0. So the light travel from the denser medium to less dense medium. Okay, so bila light travel from denser to less dense medium, kita nak kat sini, denser to less dense, so dia akan tak ada phase change, no phase change. Okay, no phase change. Okay, no phase change. Kita tulis sebagai NPC, no phase change. Okay, so kita tengok kat sini, kita nak describe with the aid of diagram the interference of light in the thin film at normal incidence. Okay, kita limitkan kepada 3 medium saja. Okay, kita limitkan pada 3 medium. Okay, so sekarang ni I nak lukiskan sendiri. Okay, kita tengok lukisan. Alright, so kat sini contoh kita ada case number 1. Case number 1. Okay, we have 3 medium. Okay, so ingat, kita ada N1, N2, N3. Saya kata 1.0, 1.33, 1.52. Ini contoh. So ingat, mesti N2 ni adalah kita punya thin film. N2 is our thin film. Okay, so the light rays is incident on the phase medium. Okay, and then reflect. So this one from the less to denser medium. Okay, less to denser medium. So we have phase change pi radian. Okay, so the light rays travel lagi, okay, pada thin film, and then reflected ray, reflect. Alright, so case kedua kita lihat sini, daripada less to less dense medium, less to denser medium. Okay, so ada phase change juga sebanyak pi radian. Okay, so the two rays, okay, have the phase change of pi radian. So kita akan anggapkan ini sebagai in phase coherent source. Okay, in phase coherent source. Okay, satu jenis lagi, case yang kedua, kita ada macam ni. Okay, kita ada mesti 3 lapis, limited to 3 only, and 1 1.0, and 2, 1.52, and 3, 1.33. Alright, so the incident ray, okay, and then reflected ray. Okay, so kita akan tengok di sini. Kita akan tengok pada medium ni. Less to denser medium, so phase change. Okay, phase change by radian. Okay, seterusnya kita tengok lagi incident ray, and then we have the reflected ray. Tengok kat sini, denser to less dense medium. So from denser to less dense we have no phase change. Okay, phase change kita adalah 0 radian. So ini kita namakan sebagai anti-phase coherence source. Okay, so untuk kes ini kita ada dua jenis sebenarnya. Okay, we construct a table for the thin film. We have to know the equation used. Okay, so you have in phase and anti-phase. Okay, kat sini kita ada in phase. Satu lagi kita ada anti-phase. Satu kita ada constructive interference where appeared bright. Satu lagi kita ada disruptive interference where appeared dark. Okay. Okay. So kat sini ini adalah kita punya delta L. Okay, ini adalah kita punya delta L. Delta L tu apa? Delta L tu adalah dia punya path difference. Okay, path difference untuk kita punya thin film kita gunakan 2NT. Macam kalau double slit kan. Okay, double slit kita gunakan delta L sama ada M lambda ataupun delta L sama dengan M plus dengan half lambda. Okay, so dekat sini untuk kita punya delta L adalah 2NT. N tu apa? N tu adalah thin film yang kedua. So 2NT equal to M lambda, and this one 2NT equal to M plus dengan half lambda. Okay, this is the equation yang telah dikaji. Kita tak payah nak kaji lagi. Okay, so untuk anti-phase, okay, kalau kes untuk anti-phase, satu ada phase change, satu lagi tak ada phase change, kita akan guna yang ni 2N2T equal to M plus half lambda equal to M lambda. So you have to know that to find the T minimum, M equal to 1. To find the T minimum, M equal to 0. To find the T minimum, M equal to 0. To find the T minimum, M equal to 1. Okay. Tengok kat sini pula untuk first cases. Okay, N3 is greater than N2 is greater than N1. So 1.0, 1.5, 3.5. Okay, so kita tengok punya lukisan kat sini. Okay, so ni from less to denser medium, less to denser, so akan ada phase change. Okay, we have this one, phase change sebanyak pi radian. Okay, sebanyak pi radian. Alright, so for this one dense, less to denser medium. Kita tengok kat sini, less to denser medium pun ada dia punya phase change. So ni kita namakan dia sebagai in phase. Okay, coherent source. Okay. Okay, so second cases kita ada 1.0, 1.23 and 1.0. Okay, so kita ada light rays. Okay, incident on the air and the thin film. Kita kat sini less to denser medium, so akan ada phase change sebanyak pi radian. Okay, but this one we have 1.23 and 1.0. 1.23 and 1.0 is denser to less dense medium, so no phase change. Okay, 0 radian for the phase change. Okay, this is the explanation When an incident ray falls on a thin film surface almost normal to the surface point B. Okay, so the division of the amplitude occur. Part of ray 1 if reflected. Okay, ray 1 adalah ray BE. Okay, so ni penting. Part of ray 1 reflected. Nombor 2, part of ray are refracted and reflected. Refract and reflect. So ray 2 is refract and reflect. So B, C, D, F. Okay, B, C, D, F adalah kita punya ray number 2. B, C, D, F is refracted and reflected. Okay, point D is very close to B. Okay, B and C become straight line. Okay, so yang penting kat sini kita kena tahu yang dua ni. Part of ray 1 reflected, part of ray 2 refracted and reflected. Okay, at B, okay, ni explanation. The reflected ray undergoes pi radian phase change because the ray 1 reflected from surface of higher refractive index. Okay, so kat sini kita ada phase change because N2 is greater than N1. Okay, yang ni saya namakan N1. This one is N2, this one is N3. NA, N2. Okay, NA ni N1 lah. N2, N3. Kita punya thin film mesti N yang kedua. Okay, at C, the reflected ray undergoes pi radian phase change. Okay, because from less to denser medium. Okay, ni from less to denser medium. Okay, therefore both ray 1 and ray 2 are two coherent source. Okay, dia letak L for the constructive interference. Kita ada 2nt equal to m lambda, and this one for the destructive interference 2nt equal to m plus half lambda. Ini adalah untuk in phase. Okay, ini adalah untuk in phase. Yang ni pula satu lagi. Okay, at B dia ada apa? Dia ada pada dia phase change, tapi dekat C ni the reflected ray undergoes no phase change. So kita namakan dia sebagai anti-phase. Okay, so untuk anti-phase 2nt sama dengan m plus dengan half lambda. For the destructive interference 2nt sama dengan m lambda. But you have to know that the n must be n number 2. Okay, must be n number 2. Where to find the T minimum, m mesti sama dengan 1. To find the T minimum, m sama dengan 0. Minimum m sama dengan 1. T minimum m sama dengan 0. Okay, kita try pula example number 6. Okay, kita try example number 6. Okay, dia kata apa? Nearly normal incident white light falls onto a glass block whose surface is coated with a thin uniform transparent film. The refractive index of the film is 1.38 and that of glass block is 1.52. Determine the minimum thickness. Okay, reduce reflection. Okay, so perkataan reduce reflection ni menunjukkan disruptive interference. Okay, wavelength is given. So first one you have to draw the layers. Okay, N1, N2, N3. N1 must be A lah. N2 is the film 1.38 and you have 1.52. Sebenarnya dia macam ni lah. Okay, macam saya kata lens kan. Okay, we coated with the film. Okay, coated with the film. With the film. Ini lens tadi. Lens. Okay, so ikut lapisannya kita ada A, lepas tu kita ada N2 1.38 and then kita ada lens 1.52. Okay, so the incident ray come from here and then reflect wing. Less denser medium, so phase change sebanyak pi radian. Yang ni pun sama, refract and reflect. So kat sini less denser medium pun ada phase change sebanyak pi radian. So ini namanya in phase coherent source. Okay, so bila in phase coherent source, dan soalan nak tanya minimum thickness, tapi dia lah destructive. So 2n to t equal to n plus half lambda. Okay, 2n to t equal to n plus half lambda. So 2n2 is 1.38. So t minimum 0 plus 1 half, where lambda is 500 times 10 power of negative 9. So you can find your t minimum here. So number 7. Okay, nearly normal incident light wave. Okay, 600 nanometer falls onto a thin uniform transparent film in air. The refractive index of the film is 1.34. A very bright rays. Okay, so very bright rays menunjukkan dia adalah constructive interference. Okay, menunjukkan constructive interference. Determine the minimum thickness of the film. T minimum. So seperti biasa itu lukis. Okay, kita lukis dulu. So dia ada N1, N2, N3, 1.0, N2. Sekejap. Okay, 1.34, 1.0 pada semula. So kita lukiskan dia punya incident ray, and then reflected ray less denser, so phase change pi radian. Okay, refracted ray. Okay, and then reflect denser to less dense, so no phase change. Okay, so ini akan jadi anti-phase. Okay, anti-phase coherent source, dan dia adalah very bright rays. Okay, so ingat balik table kita. Okay, ingat balik table kita. Kita macam ni. Yes, macam ni. Ini dan ini. Okay, so ini in phase. Ini adalah anti-phase. Constructive interference, destructive interference. So ni 2nt n lambda, 2nt n lambda, but this one is 2nt equal to n plus dengan half lambda, 2nt equal to n plus dengan half lambda. Okay, kita nak guna yang anti-phase. Anti-phase dan dia adalah very bright. Bright adalah constructive interference. So you have used 2nt equal to n plus half lambda. So you have to find the t minimum. 2n is 1.34. We have to find the t minimum, m0. Lambda is 600. Okay, so you can find the t minimum. Times 10 power of negative 7 meters. Okay. Alright, kita tengok pada example number 8. Okay, white light is incident in a subfilm. Okay, of refractive index 1.2. The reflected light looks greyish because the red light of wavelength 670 is absent in the reflection. Okay, so bila kata absent in the reflection, terus kita tahu ini adalah disruptive interference. Okay, so the conditions for the disruptive interference, kita lukis dulu. Okay, lukis, kita punya layers. Okay, N1, N2, N3, because this is the soap film. So soap film ni macam giant bubble lah. Okay, giant bubble. Okay, macam tu kan. So ni air. Ini adalah soap. Dalam tu air lagi. So ini adalah 1.0. Ini adalah soap 1.30. So incident ray, reflected ray, less denser, so phase change by radian. Ini sama juga. Okay, denser to less, no phase change. So ini adalah anti-phase. Okay, so untuk anti-phase coherent source, kita ada 2NT equal to M lambda for the disruptive interference. So find the T minimum. So 2NT equal to M lambda. M is 1.30. T is minimum. M is 1. Lambda is 670 times 10 power of -5. So your T minimum tengok workbook pula number 7. Okay, dia kata apa? Because shows a flint glass lens of refractive index from plastic 1 coated with a thin layer film of magnesium fluoride 1.38. Okay, and 1 and 2 and 3. So this is the light rays. Sketch the light. Okay, so sketch the light macam biasa. Incident ray, reflected ray. Okay, less to denser medium akan ada phase change by radian. Okay, ni refracted and then reflect. Okay, tengok kat sini. Tengok kat sini. Ni atas tadi kita tengok dekat bahagian ni. Okay, yang ni less to denser medium tak phase change by radian. Okay, dah 42 markah. Okay, seterusnya macam tu. Ada dia punya incident ray, ada reflected dengan refracted ray. So find the T minimum. Okay, and the reflection appeared dark. Appeared dark is disruptive interference. Okay, so sekarang ni kita adalah in phase. Okay, in phase coherent source. So kita ada 2NT equal to M plus dengan half lambda untuk dark. 2N berapa N tadi? 1.38. So you have to find your T minimum. 0 plus half, your lambda is 565. So you find your T minimum. A lens is used to suppress the reflection of light at high frequency. So high frequency, what done to the thickness? So apa dia daripada minimum thickness? Kita tahu 2NT equal to M plus half lambda. So kita C equal to F lambda. So lambda equal to C over F. So 2NT equal to M plus half C over F. So when F tinggi, T reduce. Okay, because T is inversely proportional to. Okay, ni soalan number 7. Okay, untuk kita punya thin film. Okay, kita cari lagi soalan untuk thin film. Thin film. This one yang C. Okay, yang C. Okay, this one. Okay, ni. Cakap apa? Calculate the thickness. Okay, ni dah ada. So this one is number berapa ni? Okay, number 10 number 10 C. Okay, number 10 C. Abang dulu. Okay, cakap apa? Calculate the thickness of the soap film so that the 600 nanometer light is incident to the film will produce constructive interference. The index of refraction of the soap film is 1.33. Okay, ingat soap film ni, okay, macam giant bubble. Okay, kita lukis. Dia ada apa? N1 1.0, N2 1.33, N3 is 1.0. Okay, incident ray, reflected ray, less denser, phase change. Reflected, reflect. Denser to less dense, so no phase change. So ini adalah anti-phase. Okay, anti-phase current source dan dia adalah constructive. Okay, kita lihat sini. Kita punya table anti-phase current source. Okay, anti-phase current source constructive. So you have to use 2NT equal to N plus half lambda. Okay, 2NT equal to N plus dengan half lambda. So 2N is 1.33. You can find T minimum 1/2 lambda is 600 negative 9. So you can find your T minimum. Times 10 power of negative 7 decimal 3 nanometers. Okay, simple this one untuk soap film. Soap film ni thin film lah. Okay, kita tengok lagi. Alright, kita tekan sini. Soap film ni nombor apa ni? Number 11 ya. Number 11 B. Okay, a soap film refractive index 1.3, minimum thickness 0.177 micrometer, appears reddish under white light. Calculate the wavelength of the light that is missing. Bila ada perkataan missing, ini menunjukkan disruptive. Okay, tapi sebelum tu kita kena tahu dulu either kita punya thin film, kita punya apa ni, in-phase ataupun anti-phase. N2, N3 1.3, 1.1. Okay, so okay. Less denser, phase change. Denser to less dense, phase change. So ini adalah anti-phase. Okay, so untuk anti-phase kita tahu disruptive interference 2NT equal to N lambda. N is 1.3, T is 0.177 times 10 power of negative 6, 1 lambda. So lambda equal to film. So you kena tahu apa? You kena tahu yang ni pentingnya. Kena tahu yang ni. So apa-apa mesti lukis dahulu. Okay, thank you, bye.